We are going to get moving along with one of my favorite presenters. She is an Associate Data Quality Analyst with Major League Baseball, and we are going to now turn it over to Shanna Shi. Shanna, are you in Phoenix yet?
I am actually. I'm once again presenting from a hotel room.
Did you get caught in the rain?
No, I made it in before it started.
Good, good. Well, for anybody who's attending in person, I think it's only supposed to rain today. So tomorrow is going to be nice and sunny, usual Phoenix weather. But I wanted to turn it over to Shanna. She's going to talk to us about using StatCast and Baseball Savant data. We're pleased to welcome her. Shanna Shi, everybody.
Right. Hi, everyone. So thank you, Scott, for that lovely introduction. I hope I actually live up to it. So let me share my screen first of all, so I can actually load up this presentation. Slideshow. All right. So here's a little bit about my background, just so you know where I'm coming from. I did my undergrad like almost 10 years ago in psychology, and then I went on to work in chemistry doing some stuff that doesn't matter here. And then I went to grad school for epidemiology. And then after that, then I started with the Toronto Blue Jays for a few years in R&D. And then in 2021, I started here with Major League Baseball in my current role. That's all you need to know, the important bits. So what I want to talk about this next half hour is sort of like the 3 W's of baseball data. So for broader reference, my team is under baseball data platforms. So, I spend a lot of time thinking about baseball data. I spend probably every single minute of my working time thinking about it. And so what I want you to think about is, what I want you to learn, and I'll also think about, is what exactly is baseball data? Where do I get it? And what do I do with it? So those are the 3 W's we're going to be going over this in this presentation. Also, I had a lot of caffeine today, so if I talk too loud, too quickly, please let me know and I'll try and slow down. So when I talk about baseball data, this is what I refer to. So broadly speaking, this is anything that happens on a baseball field. So this includes what we at my team call core data. So this is stuff like the dates, the seasons, even play-by-play. So the record of someone striking out in the bottom of the 4th is core baseball data. So this is essentially what you get from a box score, keeping track on a scorecard. And so, when you keep score, ideally you'd be able to reconstruct a game completely from what you've kept score by. I will admit that I can't really do that with my own scorecards because I kind of trail off by the end, but this is ideally what you should do. But of more interest to me, and I'm assuming you, because you're here listening to me talk, is StatCast data. And what StatCast data lets us do is it helps us quantify any single movement that happens on the field now. And so that's stuff like exit velocity, spin rate, sprint speed, catch probability. And now as of 2024, we're getting backtrack, well, 2023 technically, but we're going to start seeing more of these stats becoming public in 2024. We're starting to get backtracking data as well. So now we really can track any single movement that happens on the field. So 2023 alone, we tracked about 729,744 pitches across the major leagues. So that's not including anything in the FSL league. That's not including anything in AAA. That is just the sheer amount of data that we had for the major leagues. So I want you to think about the entirety of a baseball play. So once again, every single movement, we know exactly where the release point of that pitch came from. We know exactly how fast Oscar Hernandez ran around the bases. Now we know how fast he swung the bat. Not for this particular play, but going forward, we do. And we know exactly where every single fielder was located. And we store all that data somewhere. This is just a brief overview of how we get that data. So new as of 2020 is, new as of 2020, we popped up, sorry, went forward a few too many slides. We switched to optical tracking. Before it was radar based, but now it is all optical. We have 5 pitch to plate cameras and 7 cameras also focused on fielder. 4 of these cameras are focused on the batter and the pitcher, and those are at high frame rate, 5 of them are at high frame rate. And so those focus on getting the frame by frame movement of both the pitching delivery and the bat swing. So yeah, a fun game to play if you walk around stadiums is looking for the Hawkeye cameras. I do this now because this is my life. And you can see this is just a brief clip of how exactly pitch tracking is conducted optically. Now we can see the movement of the ball frame by frame, and we can see the seams on the ball is how we track spin rate. And so that's how we get all that fun stuff that Baseball Savant does. And then also going into this, oops, sorry, I did not mean to end that slideshow. R and R Studio, those are what I work in. That's what the rest of this presentation is going to be done with. So R is a free open source statistical programming language. One of the biggest benefits of R is the absolutely massive number of user-coded packages. So there's stuff for like analyzing phylogenetic trees, like biological data. Of particularly interest to us is probably going to be stuff like tidyverse, LME4, which is a statistical modeling package, the Lamin package, or Baseballer. And RStudio is just an integrated development environment for R, and it just makes programming in R easier. All right, so now the next question is, where do I get baseball data? And so I know some of you probably were here for the Introduction to Baseball Databases talk earlier today. I won't really go over where to get most of these sources, but you can use stuff like Baseball Reference, you can use sources like RetroSheet. And then the next three, Baseball, or Baseball Computer, are not necessarily sources, they're ways to interface with that sources, with those sources. I won't be going over either of those too much in this presentation either. We're going to use a good old-fashioned CSV download. And of most importance, and I'm assuming why you're here, is Baseball Savant, which at this point, we are going to switch over to the actual Baseball Savant website. So Baseball Savant is the public-facing warehouse for all of StatCast data. So as you can see, it's a lot nicer than what I have to work with internally. And there's all sorts of fun things like pitch visualization, statistics, leaderboards, highlights of plays. We can see trending players, that sort of stuff. I'm not actually part of the Savant team, so I'll let someone someone else can probably explain the fun parts of Savant more than I can. But one fun thing that you want to probably play around with if you're interested in working with baseball data is the StatCast search. So I've sort of preloaded a query that we're going to be working on later, but you can choose different pitch types groups. If you want to look at fastballs, for example, if you'd like to choose like a certain batter, you can, we can find Ohtani Shohei and like see how he does against these pitch types, for example. And then you can choose what kind of stats you'd like to look at. So if I want to look at WOBA, or if I want to see results, I can look at that sort of stuff and also like filter. I'm not going to reload this query, the query that I'm looking at, but once you get your results, what you can do is you can download these groups. So right now, these are all grouped by pitcher and pitch type. So you can download that group data by clicking the floppy disk icon. And then if you want to download pitch by pitch data, like each individual pitch as one row, then you can click this button here, which will download everything as a CSV. This one takes a little time to download if it's a larger query. So I have already downloaded it, and we are going to load that into R right now. It's actually already loaded into R, but so now we're getting into what do I do with this data? And so I'm going to walk us, there are a lot of things you can do with baseball data. You can do anything you want with baseball data. I say that the best baseball project to do is the one that you're interested in. So this is just an example I came up with really quickly. But let's say we have a hypothesis that lower exit velocity, that higher spin rate on the slider group of pitches is going to lead to lower exit velocity on balls hit into play. The mechanism is possibly that more movement means that it's harder for a batter to score up on pitches. And so this is the only library, the only library I'm loading in. I'm loading in tidyverse just to help with data cleaning. And then we can import our data here. That's what I've done here. And then when cleaning that data, we can filter it so that we have balls hit into play only. This is actually probably a huge source of selection bias, but we are not going to worry about that right now. This is not a course on going to study construction. So one good thing about tidyverse is that it includes ggplot, which is a really powerful package for making and creating graphs in R. They quote unquote are publication ready, but I would not call this publication ready because it's still pretty messy. But as you can see, it's a pretty neat way to be able to look at all of your all of the events that came out. So right now we're looking at what we have on the x-axis here. This is spin rate in rotations per minute, and then on the y-axis is launch speed. And this is for every single event that happens for every single ball in play. So we can see most of these are going for field outs. We have a lot going for singles. We have a couple sack bunts here, a couple sack flies. And so I'm going to be honest, I'm not really seeing much of a relationship here, so it's not looking good for my hypothesis. But we also have a lot of different variables, and it would be nice if we can combine some of these things, like the doubles and triples and singles and hits. This might not actually be what you're interested in. Maybe you are interested in looking at home runs separately from singles and hits, but for now, let's just combine these for simplification. So you can see here, this is a small aside, but you can see here that I keep making new data sets when I'm transforming variables and cleaning my data. And this is just so in case I mess up somewhere, I still have my original untouched data set. So I can redo anything if I have to. This is just usually a good thing to keep in mind when you're cleaning data. So here I've just made a new variable that classifies doubles, home runs, singles, and triples as a hit, and anything else is an out. Before that, I'm also just filtering out sack bunts, sack flies, and field errors because there are not that many of them, and I think that's just going to confuse results. Just also, it's a good idea to just double check your work and make sure that your variables coded the way you wanted them to, because sometimes they don't, and then it's better to find that out now and not at the end of the work when you've already done your statistical analysis. So we can see here that all the things that are hits are coded as hits, and everything else is coded as an out. This is exactly what we wanted. And so now we can take a look at our data again. And we can see here, this is just another demonstration of what ggplot can do. We can see we have spin rate on the x-axis and we have launch speed on the y-axis. I honestly don't see much of a relationship here anyway, just visually, but I mean, we can keep going with this anyway, just to play this through to the end. As you can also see by the legend, these are color coded. So we have the little blue dots are balls in play that are hit for an out, and then the pink ones are hits. But since we're here, we might as well run a quick linear model. This is just a really quick linear regression. I've done absolutely no controlling for pitcher or batter or pitcher or batter identity, which I would normally do, but we'll go for it. And so this is just assuming that launch speed is going to be, launch speed can be predicted by a combination of the release spin rate plus the type of hit that it ends up going for and the pitch type. Once again, this is probably not the best constructed model, but it's okay. So that model converged, which is good. That's a good sign. Sometimes they don't converge. And we can look at the results, which these aren't looking very promising, honestly. But we can also look at how we interpret this. So one way to look at this is that for every single RPM that spin rate goes up, launch speed goes. Basically, what this is saying is actually that launch speed is barely affected by spin rate. We can see here that the confidence intervals are approximately these are basically zero in terms of the units of precision that we work with in terms of exit velocity. There is, however, a relatively large effect for the type. So we see that launch speed for outs are a lot lower than the launch speeds for hits, which makes sense when you think about it. And also, these two pitch types end up with lower launch speeds than the slider, which is using as a default. This is probably not the best explanation of how to interpret linear model results, and I'm sorry for that. So sorry, I think I spoke a little quicker than I meant to, and that is actually the end of my presentation, but yeah. Any questions? Okay, thank you. I will take that silence as affirmation that it was an amazing presentation and everyone understood every part of it.
Now here come the questions, Sean.
Here we go. Okay, any anticipation for the effects of AI on analytics in baseball? Can I get a clarification by what you mean by AI? Do you mean generative AI or do you mean machine learning methods? Okay, in the meantime, I'll see some. So I am probably a bit of like a old school person when it comes to this. So machine learning is just it's just fancy regression. Like everything is just they're just more advanced regression methods that we've all been using. So if we're talking about machine learning, they have like we've been using these for ages already. Like the classic like for example, so how we determine pitch type by StatCast is we get that pitch data basically instantaneously it's basically instantaneously. It's like a 250 millisecond latency. And so what that does, like the characteristics of that pitch type get loaded into a neural net. We have neural nets for every single pitcher, and that neural net automatically determines what kind of pitch type it is. So they're customized for each pitcher, so with their exact repertoire, and we have people always changing them. So we learn like, hey, this guy picked up a slider over the off season, that gets added in. So now the neural nets know like, oh, there's like oh, I need to look out for this guy throwing a slider as well. So we've been using machine learning for a while, is what I would say. So I don't know if there's necessarily like a larger impact coming because it's kind of already been integrated, if that makes sense. Let's see. Yeah, in terms of Python and R, it's either is fine. Like if pretty much every organization will have a mix of people who use both. I don't think there's an advantage. Well, each one has advantages over the other, but if you learn one of them, you're solid. I can't think of a single organization that would be like, no, we can't take you, we'll use Python here. Loading data from Savant into R. So honestly, this time around, I just downloaded a CSV. You can see here, it's savantdata.csv, and then I just use the very handy default read.csv function to load it into R. You can use things like Baseball R or PyBaseball to get data from Savant, to like scrape Savant, but I am technically not supposed to be talking about those because they're technically not allowed to be, so I'm going to stop talking about that actually. So downloading the CSV, loading it in via CSV reading function, completely fine, totally fine. Part of the big switch of why we switched from radar to technology, radar is so we could get player tracking, player and post tracking. So with radar, we couldn't get any of that all. And now we have both like the low frame rate skeletal stuff. So that's at 30 frames per second. You know, that's how we know like if the second baseman like raises his arm, we know now like when he raised his arm, where his arm is. And then also, now that we have the high frame rate stuff, we can get batter and pitcher biomechanics. So this is when we're really getting into stuff like how fast did a guy swing a bat? How much did the bat miss the ball by? That sort of thing. Let's see. I think one of the big advantages of R is, first of all, like package management and loading is much simpler than in Python. And also like graphics are much easier to do in R than in Python. Like ggplot is really powerful, and there's just like so many user source packages that are really easy to like pull and load, unlike in Python. Python is probably more powerful and also quicker, which is less important for stuff at like this sort of complexity. But if you're running like much like more complicated regressions with or like more statistically advanced models with a lot of data, that sort of thing starts becoming in handy more. And I think also like Python is probably easier to interface with other languages, or if you're like trying to run like an automated workflow on a daily basis, Python might be easier to integrate into that sort of like that sort of cron job. Let's see. With the J, so as an intern, I just did intern stuff, so operating cameras, running around, getting coffee, that sort of thing. I also did a couple things like let's see, I think like a scouting one, can we make like a tool to just sort of like see how someone's batting average would go up if they started putting more balls in play. It's like, okay, so let's whip up like a spreadsheet. Or, if you want a statistical model based on, God, what did I do? It's been a while. Everything from like before the pandemic, like I barely remember it. But so yeah, like statistical models, if there's anything interesting, I remember I started looking at the effect of mound visits on pitching performance, that sort of thing. And then when after my fellowship ended and then this job came up, I applied, and I love just having control over what the future of baseball data looks like. So it's very fun to me. How similar is R to Python in terms of learning the language or language structure? I don't actually know if I don't think I'm the best person qualified to talk about this because my Python isn't the best. I mostly use it for web scraping and that sort of thing. I don't think they're that hard to pick up if you know one and know the other. So yeah, I don't think they're like that as far apart as like say like R, and if you're trying to work with like Lisp or Go. But I don't think, sorry, I don't think that's a very helpful answer actually. But I think if you pick up one, you can pick up the other. How would you recommend getting into R for someone who has no experience with it? Or online courses plus research the best way? Someone already recommended analyzing baseball with R, and I see 2 thumbs up for that. I am also going to agree with that. I think that is a great way to get started with R. I think, especially because a lot of the tutorials you see online will be like, hey, let's look at the default cars photos, the default cars data set again. And like, I don't care about car model like gas mileage. I don't care about like iris sepal lengths, but I do care about baseball. And so analyzing baseball data with R has a lot of like what we call motivating examples. And it's all stuff like, how do we look at this sort of model based on baseball data, which it also introduces you, gets you to pull for yourself. So yes, highly recommend that book. Also for like the very, very basic beginners, there's a package called Swirl, which is basically runs you through like a really basic tutorial in R, and I recommend that as well because that's how I first learned. How did I transition into baseball after majoring in psychology? Honestly, it's more of like so I thought I was going to be a doctor, and that's why I went to public health school. And then when I was in public health school, I realized that a career in baseball was actually a possibility. One of my mentor consulted for Major League Baseball teams and does football analytics, and so that's when I realized. And I started doing baseball research on the side as I was sort of like trying to really grasp the concepts I was learning in class for myself. And then I went and I presented it at SABR seminar, and I was just going to go have fun and then go back to my life of bacterial infections. Except then clubs started coming up to me and asking, hey, like, what are your plans after graduation? That's when I realized like, oh, like this is actually a possible career path. And then I just pivoted and went full on into trying to get a job in baseball. And now I'm still here. Will backtracking include both bat speed and bat path / swing plane? Yes, it will. Can I go into my job role a bit and how I started out and progressed through the ranks? What essential skills you learned at which points of your career? Let's see. So yeah, I started as an intern. Now I'm here. I think one of the most important things I've learned is how to talk to people, especially people who aren't at the same level of technical understanding as you. I think communication is probably one of the hardest skills to pick up and one of the most important. So in my current role, one of my duties is live game support, and so seeing a lot like if something goes wrong down the StatCast pipeline somewhere, whether that's like a server down and so that data isn't getting delivered, or something like a camera goes down, so we're not even getting that data in the first place. It's not my job to know how to fix it, but it's my job to know who knows how to fix it. And so being able to communicate with like all of these different stakeholders, all these different teams from within MLB, and then people from clubs, people from broadcasters, people from other vendors like Sports Radar who want to know why aren't we getting this, that's really important. And even if you want to stay club side, or if you want to go, third party or something, being able to communicate, because if you go into analytics with a club, you're going to be talking with coaches, you're going to be talking with scouts, and they're not going to have the same background as you. So it's important to be able to meet them on their level and say things in a way that everyone can understand, because there's no point in making like the world's greatest model if no one understands what you're talking about. Let's see, how long would you estimate it takes in order to being effective in using Python? That's a great question. I don't know if I can necessarily answer that because I just kind of went straight for it the first time I started using Python to web scrape. So I don't know if I can actually answer that question. I'm sorry, I'm not familiar enough with Python to be able to do this. Since there appears to be little to no effective spin rate affecting velocity in this example, how would you further adjust the model to further test your hypothesis? That is a really good question. I would straight up just throw this hypothesis away and get a new one. Honestly, I came up with this one in about 5 minutes, and I don't think it was the best example, especially because I think there is a lot of sample size, but I think I probably would have actually switched to maybe doing something more like a logistical regression and seeing if spin rate has an effect on the probability of something going for a strikeout or an out in general. Or, if I wanted to go into something a little more complex, see how this following like a fastball, for example, or preceding a fastball might affect the probability of like that pitch being swung on and missed. Because I think the combination of pitch sequencing is probably going to be more effective than just and take the entire at bat into context rather than just looking at this alone. Do I have advice or tips on navigating working in professional baseball as a female? This one is tough for me to say because I don't know what it's like to be a man in baseball. I'm just me. I think knowing that you have the right to be here and like being able to keep speaking up and like just don't be afraid to speak up, don't be afraid to like interrupt people and be like and give your opinion. And I think just keep going for it, keep reaching out. That is my best advice. I'm sorry, I really don't have specific advice. Who would you say benefits the most from your work, MLB owners or players? I think this is a really good question, actually, because I don't know if I can say one in general. I would consider our biggest stakeholders the clubs, the broadcasters, and then after that, the fans. I'm sure my director might disagree with me on that. But if you think about StatCast, who uses StatCast? So obviously you have, obviously like the clubs lean on this really heavily for all of their analytics. That's what powers a lot of their analytics. But on the other hand, you know, if you look at the way people watch baseball now, everyone is always talking about pitch velocity. Everyone, like now we're talking about spin rate. We see people talking about seam shifted wake, sprint speed, catch probability. These are things that fans are talking about as well. And so I don't know who benefits the most from that. Like, I guess then it's just a value question of, do you think clubs benefit more from having advanced analytics, the data to power advanced analytics than fans benefit from knowing exactly how fast the pitch is thrown? I guess when I put it that way, it sounds like the clubs benefit more, but I don't know how to put a value on fan entertainment like that. I'm sorry. Is each team getting this information from MLB without use of Hawkeye tracking on a daily basis? Yes, they are. They are getting this data basically live. Yeah, basically live. Yeah, once again, do more organizations tend to use Python or R? I see a lot of people have answered this already, and I'll reiterate, yeah, it doesn't really matter which one you use. And I do agree with Alexander's advice that the best advice is to be very strong at one language rather than trying to do both. Like I'm mostly an R person. I do Python if I have to, and mostly just for like web scraping or that sort of thing. But day to day, like I prefer to stick with R. Are full body pitching and hitting kinematics going to become publicly available? That is not on the roadmap. I'm sorry. What is the biggest difference between working for the league compared to a team? I think the biggest difference is that I get to be like a baseball fan again. Before, you know, it was a team was like, what do we do? Like, what do we do to help the team bigger and win? And rather than now, I'm just like, oh, like that was really cool. And I don't care that it was a guy who played for like a team that used to be like a Jays divisional rival. So I think that was the biggest difference. The other part is that like I have a little bit more time to like play around with stuff that I think is cool that might not have a direct benefit on helping a team win. So I think it works better. But actually the biggest difference is probably that I can look at things more from like a top down kind of level. So I can look at like league wide trends instead of just focusing on like one player. And this is going to be the last question. Does MLB try to categorize pitches based on what the pitcher thinks he's throwing, or by the characteristics of each pitch? So there's a very like strong philosophical debate about this. And Tom Tango with the Savant team, he thinks we should do the latter, but we do the former. So if a pitcher says he throws like a slider, but it's more like a sinker, we're going to call it a slider because he calls it a slider. And sorry, I know I said that was the last question, but catch probability, I can't go into that, and I can't go into that right now. I'm sorry. And advanced pitching metrics are all available on Savant. I will end it here. Thank you, everyone.
Shanna, that was great. Thank you so much.